Let's take a look now at the idea of using the inverse trig functions, and I'm using these inverse trig functions for differentiation and integration. So let's take a look at a few of the learning objectives here that we want to try to accomplish in the next series of videos. First of all, I want to develop the properties of the 6 inverse trigonometric functions. Then I want to be able to differentiate inverse trigonometric functions, and ultimately I want to be able to integrate the functions whose antiderivatives involve the inverse trigonometric functions. Now, as a quick review for inverse functions, you know that a function has an inverse that is a function only if the original function is actually a one-to-one function. That does not satisfy any of the trig functions. None of the 6 trig functions actually have inverse functions because they're not one-to-one. However, we can restrict the domain and get a one-to-one relationship over a restricted domain. So consider just a moment, say, sine of x. So here's sine from negative pi to pi. I'm sorry, negative 2 pi to 2 pi. Notice clearly this is not one-to-one. However, if I restrict my domain, if I think of sine only from negative pi over 2, which would be right here, to pi over 2, which is right here, so if I restrict sine to just that domain, you see I've covered the entire range. So it doesn't matter where I am on sine, I can always relate it to this restricted domain. This is now one-to-one. So if I restrict the domain of sine, I can have a one-to-one function. So sine of x is in fact monotonic on negative pi over 2 to pi over 2, and the range is negative 1 to 1 because I reached the minimum here and the maximum here, and we all know that sine has a range of negative 1 to 1. So inverse, which we refer to as arc sine of x, okay, the inverse of sine, arc sine of x, then has a domain of negative 1 to 1 and the range of negative pi over 2 to pi over 2. As you may recall, and if you don't, you may want to break out an algebra book and do a little reviewing or ask questions on the basic idea of inverse functions. But if I have a function whose domain is negative pi over 2 to pi over 2, and then look at the inverse, the domain becomes the range for the inverse. What was the range in the original function becomes the domain for the inverse. They switch places. So let's take a look at the 6 trig functions and how we can restrict the domain so that we can make a one-to-one function and get, in fact, an inverse over that restricted domain. So arc sine of x. Y is equal to arc sine of x, the inverse of sine of x, if and only if sine of y equals x. That's just the basic definition of an inverse function. Now my domain is going to be negative 1 to 1. This is for arc sine. And the range will be negative pi over 2 to pi over 2. Now the function y equals arc cosine of x, that's true if and only if cosine of y is equal to x. Again, that's just a basic definition of an inverse function. Now the domain will be the range of cosine, which again is negative 1 to 1. But the range is going to be the domain of cosine. And if I restrict cosine to be between 0 and pi, I will get a one-to-one function. This is cosine of 0, and right here would be pi. So it's 1 to 1 on that restricted domain, just like up here with sine. When I restricted sine to be negative pi over 2 to pi over 2, I got a 1 to 1 function. It's the exact same idea. Now continuing with these other trig functions, y equals arctan of x if and only if tangent of y is equal to x. That's, again, the basic definition. Now, you know the range of tangent is negative infinity to infinity, so that must be the domain of the inverse. And we also know, I'm going to slip it in right here because I drew cosine over here, that if I restrict tangent to negative pi over 2 to pi over 2, I will in fact have a one-to-one function. Now what I really suggest you do is produce these graphs in either Maple or Mathematica, whatever you happen to be using at the time, to actually take a look at some of these graphs, restricted domain, and see what they look like. Don't take my word for it. Produce the graphs of these functions over the restricted domains, and you will see that they are in fact one-to-one. Now, arc cotangent of x, y equals arc cotangent of x if and only if cotangent of y equals x. Again, that's just your basic definition of one-to-one function. And cotangent also has a range of negative infinity to infinity, so that must be the domain of the inverse function. And if I restrict the domain for arc cotangent from 0 to pi, I would get a one-to-one function, so that must be the range of the inverse. Now, continue with secant and cosecant is the exact same idea. The domain is going to be absolute value of x is greater than or equal to 1. And it's the exact same thing for cosecant. And then, of course, if I restrict the domain of cosecant from 0 to pi, not equal to pi over 2. And for, I think I said cosecant, sorry, I'm talking about secant. And for cosecant, if I restrict that domain from negative pi over 2 to pi over 2, not equal to 0, then I will have one-to-one functions. Now, just as a quick reminder, what is secant? Secant of x is 1 over cosine of x. That's why we have to restrict it and cannot let x equal pi over 2, because at pi over 2, cosine 0, 1 over 0 is undefined. Likewise here, a cosecant is 1 over sine of x. That's why I have to restrict the domain here, non-zero, because if sine is 0, I have, again, an undefined function. And remember, I'm making reference to the domain here because I'm talking about cosecant and secant. But remember, the domain is actually the range when I start talking about the inverse functions. Now, we very commonly use a shorthand notation for arcsine, arcsecant, and so forth. And that shorthand notation is simply arcsine of x we write as sine with a -1 exponent of x. Now, this exponent is not an exponent. It is an inverse notation. Remember f of x, if we found the inverse of f of x, it was f with a -1 of x in the exponent's position. But that's not really an exponent. If I wanted f to the -1, I would write f of x to the -1. That would give me 1 over f of x. Sine with this notation is not an exponent. This is saying it's the inverse. This is not equal to 1 over sine of x. This is not a -1, not an exponent of -1. If I wanted 1 over sine of x, that would be sine of x, the whole thing, to the -1. So just to help keep some of that notation straight.